Abbaspour, Senior Manager at OAuth2, to talk about some common OAuth2 mistakes to avoid. Thanks.
Hello, everyone. My name is Amin. I am glad to be here, thanks to API Days Hong Kong, with you guys to talking about some of the common mistakes I've seen when implementing OAuth2 to protect your APIs. I work for Okta. I'm part of the professional services team in the APAC region. And these are the common mistakes that I've seen among our customers or in my previous roles in the API security. And I would like to share them, hopefully to get some value out of it. And if you find any of these applicable to your environment, you have the chance to go back and improve your design and implementation of OAuth2. The areas that I've seen that these pitfalls may happen, I would like to categorize them into three areas. The common theme is security and privacy. So you might see the designs or implementation that suffer from security issues, or they jeopardize the end user's privacy. So these are the things that we should avoid. And there is a lot of information about these security flaws in the best practices documentations and white papers for OAuth 2 and 2.1. After security and privacy, obviously availability of the system, so the designs that may also impact your uptime, your availability, or your performance. These are also things to be mindful of. And also the scalability of the platform. So you have an API protected by OAuth2, how you can design the system to be more scalable, so you can expand the system, scale it, and add more clients without suffering any of the scalability issues you might have. So as we go through the next 20 minutes, I will be talking about 20 topics, and you can see which ones are related to which as we go. Probably the most common things that I've seen is the tendency to inspect the access token in the client side or in your relying party. So as you know, the access token by OAuth2 is something, it's an artifact that's issued for your resource server or for API. A typical access token, a JOT format, but this JOT format should be considered opaque. Like always, a client or relying party that receives the access token shouldn't be inspecting the contents of that to make any decisions. Like whatever you need to be receiving is normally packed in the ID token, which is issued if you're implementing OpenID Connect for issued for your relying party. If your access tokens are even JOT and inspectable in the client side, try to avoid them. And you can clearly see that there's an audience. The audience is your API and not your relying party. So that means if you're not inspecting your access token, you can easily change the format, switch to more advanced formats, more encrypted formats or opaque format, or change your vendors for OAuth2 without needing to go back and modify your implementation. The other thing is passing ID token as a bearer token in place for access token. This is another common mistake that I've seen developers make. And if you look at the ID token, which is an artifact, by the way, of the OpenID Connect, not OAuth2, but since these two are very close, I would like to also talk about the ID tokens as well. So ID tokens are issued for relying party, unlike access tokens, and the audience part is a relying party. In some cases, you send this as a bearer token, that's a mistake. But in some edge cases as well, you can complement an access token with an ID token. A typical example is when you would like to, let's say, authenticate the user again. Let's say the user authenticating with their credentials, and now you want to authenticate them with their social providers such as Google or Facebook, and then say these two identities are the same person, or link them in your system. So to represent that the user has successfully authenticated to a social provider, you can get an ID token issued after federating to a social provider, and then call your API with access token of existing credential-based user and the ID token of this social connection, and that would allow them to link them. So as at edge cases, you can pass the ID token as a complement to access token, but not as a bearer token itself. The second common pitfall is the third one is not using PXE. Now PXE has been around in 2.1 or 2.1. It is recommended way of token exchange. So when you have an authorization code, you need to exchange it. PXE can complement, regardless of what type of the client you have. If it's a public client or confidential client, you can still use PXE, which is a better CSRF and token replay protection than having, hey, I'm receiving an authorization code, I'm going to exchange it anyway, and my only check will be my, let's say, stage check. If when you're implementing PXE, no other client can exchange the authorization code rather than the client that started the transaction. So it is very powerful protection for your end-to-end flow, and when the moment that it comes that you need to exchange authorization code to your artifacts. Lack of full JOT validation. If your artifacts are JWT and you want to validate them, I have seen libraries that are not checking all the claims that it should be. Like, I have some typical, an access token in my left, ID token in my right, and another access token in the bottom right, and you can see that the things that I've seen, like some libraries don't check for algorithms, they accept none as an algorithm, avoid them, or if you have an ID token, check for claims such as nonce and any complementary tokens such as access token hash. So you can use this to validate your access token as well, or your C hash for your authorization code. And some developers use like a JOT validation that are basically established for OpenID Connect, aren't established for OpenID Connect, meaning that they're not going to check the nonce regardless if you pass them or not. Be careful with these libraries. Make sure that you're checking the claims correctly. And another claim to be mindful of, now depending on your vendor, is the type of the grant that the token was issued on. Like, I have two access tokens here in my left and in the bottom. One is for client credential grant. So the only way for me to say, is this a resource owner grant or not, is to look at the JTY claim to tell the difference. So the stronger these checks, the better and more secure your implementation. Confidential versus public clients. So I see implementations that, as a confidential client, there has a client ID and a client secret, but they're published on the internet. So distinction between confidential and a client that you can store its credential in a safe place, such as a server side, a regular web application, versus a public client, which is issued for your single page applications, for your native applications. That distinction, be mindful of these two different kinds and use them correctly in your design. At the same, let's say, model, we also have different kind of the grants and different types of the clients. So for the resource owner flows, if you look at the OAuth 2.1, it defines web applications or regular web applications, browser-based and single-page applications, and native applications. And our recommendation is to not to use the same client for different type of the flows that you have. You might have a mix of regular and single page application, try to avoid mixing these two, define separate clients. So the end goal is that you should have one client ID representing only one type of the client and one type of the flow. My recommendation is to even take this one step further. And if you have, let's say, native applications for iOS, for Android, for your TVs, separate them as well. So this gives you better analytics in terms of how your flow, how is your market adoption, and what are the target environments for your execution. Number 7, let's talk about the JOTs. I know JOTs is not a part of the OAuth2, but it is so widely used that we have to pay special attention to JWTs. And the other mistakes that I've seen happening sometimes is using symmetric signing. So I have 2 access tokens here, and they're very much the same, except that there's one of them is signed with symmetrically, so HS256, and the other one is a symmetric signature, which RS256. And when you're using symmetric, both the signer and the verifier are at the same level of power, so they have to share the same basically secret for the verified as well, that if compromised, someone can use that secret to issue new tokens. So recommendation is to always go for asymmetric. A private key is used for signing, and the public key is used for validating the signature. The other thing, again, on the realm of symmetric versus asymmetric, is the client secret. So if your library of OAuth2 or if your vendor support asymmetric client secret as well, try to use that as a replacement for plain text client secret that are symmetrically. And that's what OAuth 2.1 also recommends, that you should be using an asymmetric client secret, being MTLS or being private key JOT, to basically improve the security posture of your client when it comes to authenticating for client credential grants or for exchange, wherever the client needs to authenticate itself. If it's a confidential client, it should try to opt in for asymmetric credentials. Using the application grants, OAuth 2.1 has been around for a while now, and it has clearly ruled out 2 of the grants that was developers love to use, especially the implicit grant and the resource owner credential or password grant. So with the ROPG and implicit gone, you should be actually, any new application you're building, you should try to avoid them and opt in for redirect-based flow with authorization, code grant, and PXE as your starting point. Older application, obviously, they can still be using, but as you review those applications, you will have the opportunity to walk away from this deprecated grants and implement stronger flows for them as well. Using OAuth2 for authentication, again, OAuth2 it's a delegation protocol. It's not an authentication protocol. If you come to a situation that you need to implement authentication, what is the solution? Opt in for OpenID Connect, which runs, it's a thin layer on top of the OAuth2. Everything you've done, your libraries would still work with small modifications to the scopes and validation of the artifacts that are returned. You can upgrade to OpenID Connect, as opposed to doing non-standard authentication on top of the OAuth2. So the other thing I've seen, again, a misuse of OAuth2 is using OAuth2 for fine-grained authorization, meaning that I want to have the very detail of this user can do embedded into the access token. Again, that's not what OAuth2 was initially designed for, and there are other protocols and standard and vendors out there that are best suited for your fine-grained authorization models. So the scopes that you put in OAuth2, they should be intended for coarse grain, not the fine grain. That there are many, like I put 3, but there, if you do a search, you will see many of the libraries and vendors out there. Here in the Okta Auth0, we have fine grain authorization. It's been now generally available, and there are like SpiceDB from OAuth2 and many others that you can use for fine grain authorization. What happens if you try to model fine grain authorization on top of the JWT access tokens in OAuth2 is my pitfall number 12, which you end up with too many or too real-time claims in your tokens. Like you will end up in access tokens like this that have a scope. Hey, this user has this role in this product, and as you have adding more products and subsystems to your system with different role, this will exponentially grow, and you will end up with access tokens that are too big to even be carried on the network, or too convoluted and complex to implement at an access token gateway level. So avoid that. Use a separate tool, and you will not have these near real-time claims that every time the user does an interaction, you need to change them, or too many claims in your access tokens. And again, a side effect of having too many claims would be the too big access tokens. The other thing about access token is to avoid putting any confidential data inside it, like things like name and email. This could be categorized as a PII, and because access tokens could be issued for your first party or apps that are running within your organizations, those are normally okay. But when these first party or third party applications, they call the API, this access token could end up anywhere in the network, right? It might be going outside your premises to other servers where you terminate the traffic, or it could be issued to a third-party client through third-party clients that they can inspect this information and jeopardize the privacy of the end user. So avoid adding PII into the access token. Where they belong is your ID tokens. The other thing about, again, this is best practice, but if you put your API versions into your access tokens, you're preparing yourself for down the track issues, right? So our recommendation is that if you're putting the audience in your JWT access tokens, use a generic name regardless of the version. If you add version, let's say I'm going to issue an JWT for version 1 and then for version 1.1, and think about all the refresh tokens that are distributed among your clients, and they most probably can't use this is because the refresh tokens are bound to a certain audience. Like with the version change, now you have to re-authenticate all your users, right? So you like to avoid that and use a generic audience, not the versioning in your access tokens. They are about this is more in the security side, number 15, but be in the lookout for dangerous callback URLs that you allow. And this could be, the subdomains, especially that are not within your control. Let's say a developer is working on the part of the team, they have set up an Heroku app or similar that they've used for testing, and this may end up in production. The person may leave, but that URL is still one of the allowed, so they can use that. Someone can take the ownership of that domain down the track and basically terminate the authorization code exchange by having a valid callback URL listed in your production environment, or the callback URLs that are developers use, for example, that point to your local host environment. And it doesn't have to be necessarily local host. There are many domain names out there in the internet that resolve to local hosts. So careful with those, and regularly review your allowed callback for any subdomains that you don't own, or any open redirect flows. First party versus third party clients. this is the distinction that you have to be across and design. Like in a first-party flow, which is normally the typical user delegates an access to an application, is in the position of access token, can make API calls. And this flow normally, user doesn't need to consent or be across in detail because these client and resource servers, they basically belong to the same organization. Let's say a Gmail mail server and a Gmail app. You expect the Gmail app to be able to send emails and delete them and add contacts or whatnot. You don't necessarily but if a third-party company, let's say, builds a Gmail app, user has to consent what these application can do for me and for how long. So this consent is something that you have to be mindful of and design in your OAuth2 and say, okay, these applications are my first party within my org, but these are the applications that I'm going to give away for my third parties, and then allow the user to control what will happen there and the consent before they send out an access token. Number 17, permanent refresh tokens is again, if your library or your authorization server allows you to use the rotating refresh tokens, opt in for that, because with permanent refresh token, we have no way to detect if the refresh token is linked to the internet. Like anyone has that can use it to exchange and get a new access token, ID token. With the rotating refresh tokens, authorization server have a chance to detect the reuse, looking at the history of what refresh tokens have been used. If they detect a reuse of the past refresh token, that is a sign of a leak token, and they can basically revoke the full chain of the refresh tokens with this pattern. The access token that are either too short or too long-lived is another red flag. My go-to is like anything under 10 minutes, I consider as too short. Again, I'm generally speaking, not some edge cases that this means, or anything more than 24 hours, I consider as too long-lived, right? With too short or too long, you're either jeopardizing the performance and scalability of the system or the privacy. So find the right balance in this spectrum. What is the time to live of your access tokens? Stateful design, JOTs in particular are a very clean, stateless design. Once they're issued, they're going to be valid in your system for the duration. And there's a tendency sometimes I see among customers to add stateful components to this flow that, hey, I'm gonna, for example, have a whitelist or deny list of my JTIs or the identifiers of the access token in a database, and every time I'm going to check them. Yes, you can do that, but your scalability of the performance of the system is impacted, and you're unnecessarily sometimes changing a stateless design into a stateful design. So there might be other solutions, things more creative. Hey, what can I do here to keep the system in stateful model by, let's say, modifying the time to lives or using different scope for different operations rather than quickly jumping the gun and switching the system from stateless to stateful. My last one, some constraint that I've seen people implement that limits the growth of the system. For example, access tokens. Whoever has access is a bearer token. They can call your API. But I've seen API servers that limit some flows for a particular authorized party of who this token is issued. Again, some edge cases, this might make sense, but overall, if you're limiting based on your client in your resource server, that means every time I'm adding new clients, then I have to go and modify my configuration and code in my resource server. That is, again, something that people might not be cross. In 2 years' time, people completely forget, they add a new client and the system doesn't really work the way expected. So avoid these unnecessary steps for peace of mind and also easy growth of the system going forward. This was my top 20. I hope that you find value out of this And would be glad to connect if you have more questions. That's the end of my presentation. Feel free to continue the discussion in the networking area. I will pass this on to my MC now. Thanks a lot. See you next time.
Thanks, Amin. Now we'll have Avesh Kumar.
The API Connect Hong Kong 2023 conference is powered by bNovelty Limited. Check out more API-related education content on bnovelty.com or apidays.hk for more information.